Okay guys, we're going to go ahead and skip 15.3 because of our time crunch, but I did want to take a few minutes to talk about derivatives and antiderivatives and their different interpretations. So we've talked in the past about derivative, and we talked about how derivative can be interpreted a couple of different ways. We know that derivative is the same thing as an instantaneous rate of change, right? We also know that finding the derivative is the same thing as finding the slope of a tangent line. We know that finding the derivative is the same thing as the slope of a graph at one specific point. We've talked about finding the marginal cost or marginal profit or marginal revenue. All of those just mean a rate of change or a derivative. We've learned a couple different notations. We have this notation f prime of x. We know dy over dx is the rate at which y is changing with respect to x. So we've talked about derivatives and all different types of interpretations for derivative. And now, in chapter 15, we've been talking about antiderivatives. And so I'd like to talk a little bit about different interpretations for antiderivatives. We talked about in 15.1 that finding the antiderivative is the same thing as finding the indefinite integral. I could ask you to integrate, or I could ask you to find me the antiderivative, and it would mean the same thing. So I could ask you to integrate little f, which means I want you to find me his antiderivative, or big F. And remember, as soon as we find the antiderivative, we should be adding that plus c. It is a new function that represents the original function that has a derivative of little f, antiderivative. Well, if we had covered 15.3, we were going to talk about in 15.3 that finding the antiderivative, or the integral, is really the same thing as finding the area underneath the curve. So if I give you little f's function, and I give you this graph, and I ask you to find me the area underneath this curve from A to B, what I'm really asking you for is to find me the antiderivative, or to integrate. Well, because we have a beginning and an ending point, that A and that B, we call that a definite integral. So I can ask you to integrate little f now from A to B, and all that means is you're finding me the antiderivative from A to B. You're finding the original function value from A to B. Okay? So some kind of application examples. If I ask you to integrate the marginal cost from 1 to 3, remember that marginal cost is the rate at which the cost is changing, the derivative. If you integrate the marginal cost from 1 to 3, what you're really getting is the change in cost from 1 to 3, right? If marginal cost is your derivative and you find the antiderivative, you're really finding me the cost, but now we have a starting and an ending point, so we're doing it from 1 to 3. So the change in cost from 1 to 3. Or if I ask you to integrate the marginal profit from 0 to 4. If I ask you to integrate marginal profit from 0 to 4, that's the derivative, then what you're really finding is the antiderivative, or the actual cost, profit. So you're finding the profit from 0 to 4. So we can now go back and forth between derivatives and antiderivatives and know all of their different interpretations.